Hello, everyone. We can go ahead and get started. My name is Mia Sturdivant. I'm the marketing intern for the School of Data Science, and I would like to welcome you all to the 4th Annual Women in Data Science Charlotte Conference, hosted and sponsored by UNC Charlotte School of Data Science and Lowe's. The WIDS Charlotte Conference initiative aims to inspire and educate data scientists across the region, regardless of gender, and to support women in the field. With the current state of the world mainly interacting online, we are grateful for your decision to attend our 2-day virtual event and show your support for our various speakers. I'd like to extend a special thanks to all of our attendees for showing up and showing your support. I'm happy to introduce our recorded session for the hour after the final rose, using graph networks to spill the tea. Our speakers for this afternoon are leaders from Bank of America. I will now turn it over to our technical team to begin the video. After the video concludes, we will come back together as a group for a live Q&A session with our panelists.
Welcome, and thank you so much, everyone, for joining our presentation. Today, we're going to be presenting after the final rose ceremony, using graph networks to spill the tea. Here's a short preview for today's presentation. First, we're going to start off with an overview of graphs and their importance, and a little bit about the foundation of graph theory. Then we're going to walk through the best way to structure data for graphs and exploring them. Then we're going to talk about the different use cases that you can explore and study with graphs. Ours in particular will be looking at Bachelor Nation, and we'll show some visualizations around that. And then finally, we'll close with a question and answer session. I'm one of your hosts for today, Jennifer Estridge, and I'm a data scientist at Bank of America in Charlotte, and I'm joined by my other two hosts who will introduce themselves.
Hi there, my name is Samantha Singer. I'm also a data scientist at Bank of America. Thanks for joining us.
Hi everyone, my name is Lily Zhang, and I am also a data scientist at Bank of America, and we are super excited that you'll be joining us today.
So first, we're going to start off with why graphs. What's our motivation behind using this? As we all know, data is rapidly expanding in terms of its size and volume. In addition to the actual amount of data, the connections between that data is growing rapidly as well. And one of the biggest examples of this is social networks, which are expanding rapidly in the digital age. So graphs are powerful tools because they allow us to represent the relationships between two entities, which could be a person or organizations or ideas or anything else. And traditional SQL databases tend to be very inefficient at storing and capturing this information. And so that's where graph databases come in, because they're highly optimized to store this relational data and the connections between them. So with the node and edge structure of databases, we can easily perform traversals and aggregations of the data and find insights into the connections easier with these graph databases.
Next, we want to talk about when exactly you should use graph databases. So here we have a list of 6 times that, if you're doing them, you should probably just go ahead and use a graph database. So for example, if you've joined more than 7 tables together, it's a good idea to use a graph database. If you've ever just modeled a graph in a table, go ahead and use a graph database. If you've ever tried to write recursive SQL statements or you store relationships, you can use a graph database to do all of that. And in fact, if you do use a graph database, it's more optimized and you'll be able to return your results quicker. And in a way, you'll also have more clean data. So if you're working with hyper-connected data like social networks or recommendation engines, you can use graph databases. And if you need to apply some kind of graph algorithm to find shortest path or the relationship between 2 items, you can use graph databases. I feel like I just said graph databases a lot there.
Given all this motivation behind using graphs and unleashing their power to explore relationships, Bachelor Nation represents an extremely valuable use case to apply all of these graphing techniques. The Bachelor is a TV series that first aired in 2002, so that's almost 2 decades ago, full of seasons and relationships that are filled with lots of drama and breakups and friendship. So all of these relationships and connections that have been built in between the bachelors and bachelorettes and their contestants in modern times have spilled onto social media platforms on the internet, where their relationships are documented for the whole world to see. So with that information, we can really explore that with the power of graphs, which is what we're going to demonstrate in our presentation.
Really quick before we dive into our presentation, we wanted to talk about the data that we have from The Bachelor. And so in order to put together the data set, we pulled together all Bachelor contestants through a 538 data set that had historical data. And because it wasn't updated to the most recent seasons, we went ahead and scraped the web to pull in that information. The second part, once we pulled in all of our information, is making sure that we had consistent data. So for all of our contestants and our hosts and our bachelorettes, did we have the season that they participated in? Do we have their role? Were they a contestant? Were they a lead? Do we have their age, occupation, and hometown? So we just wanted to make sure that we had consistent data for all of our contestants. From there, we went ahead and pulled the Twitter handles and the accounts that each individual followed. Of course, we know that the majority of Bachelor Nation is more active on Instagram, but because of the Instagram terms and conditions, we actually couldn't pull their information. But Twitter provides a great API for everyone to pull their account information, as well as their followers and tweets. So we went ahead and just went with the Twitter option in this case. After we pulled in all of our information, we uploaded this data to Neo4j as nodes and edges, which we will show very shortly.
Okay, so now we're going to go over a little bit about the foundational elements of graph theory. So what are graphs? Graphs are composed of 2 different elements, a node and a relationship, which is represented by the edge. The node represents some kind of entity, which in the case of Bachelor Nation will be the person or contestant, and the edge represents the relationship between them. And a graph structure contains a set of all of these nodes and their connections. So like I said, for the purposes of this exploration, our nodes are going to be the contestants and the edges are the relationship between them. So we will be using Neo4j, which is the graphing platform that we use to analyze all of these relationships. And in this case, we have Hannah B and Jed as your nodes because they were both on the show. Hannah B is labeled as a bachelorette and Jed is labeled as a contestant. And these labels represent categories that we can put on nodes that help us find them in a graph. Nodes can have multiple labels on them, and the labels increase the efficiency and speed of querying. So actually, Hannah B could technically be labeled as bachelorette and a contestant since she appeared on Peter's season. And then in the middle between them is the edge, which represents the connection between them. So in addition to just their relationship and connections, we can also store important information about each of the nodes. So you can see here for each of Hannah B and Jed, we have properties including their name, their Twitter handle, and their age. And then for the edge relationship, we have the property of season 15, which is the season that they appeared on the show. There are several types of graphs that exist. So first is directed versus undirected graphs. A directed graph has edges that have a direction on them. So our example here shows that Lily follows Rachel Lindsay on Twitter. So you can see the direction is pointing from Lily to Rachel. There are also undirected graphs, which which have edges that don't have directions. So the edge indicates a two-way relationship. And when we're using Neo4j, it always uses directed graphs. You can also have unweighted graphs where the connection doesn't have a weight. And then there are weighted graphs where the edges have weights that indicate the strength of the connection between the two nodes. So in our example, we have Hannah and Jed again, and their relationship is weighted by the amount of time that they were together. They were only together for 2 days, so their connection has very small strength. And in unweighted, in Neo4j, you can add properties that will add value to the weighted, and those weights can be used in certain algorithms.
Thanks, Jennifer. The next part that we want to talk about is data models, or how do we set up our graph database in such a way that we can query the data. So let's dive in on how we set up our graph database. All right, whenever you set up your graph database, the first step is to think about how you want to set it up. And so in this case, you want to think about the questions that you want to ask the database. So a good rule of thumb is to use nouns as nodes. So for example, in our case, we used the Bachelor Data. And as we'll go into on the next slide, the contestants are nodes, and the following relationship on Twitter are edges. Like Jennifer was explaining earlier, labels are the categories that group nodes together. So for example, contestants is an example of our labels, and we can have different properties that describe each entity. So this is a little bit different than your relationship RDBMS systems, which have columns and rows. So instead, we have nodes, edges, properties, labels. So while you're whiteboarding, it's important to think through each iteration and think really carefully about the questions that you're posing so that you can efficiently answer each of your use cases. Okay, so let's apply it now to our Bachelor Nation dataset. Like I said a second ago, our nodes are our contestants or our individuals within Bachelor Nation, whether it be a contestant, whether it be the Bachelorette Tasha, or it is the Bachelor. These are our nodes. So for example, each node can have different properties. In our case, we have a name, so Zach, we have his Twitter handle, we also have his age, and we have his season. For each of our edge, an edge represents the relationship. So Zach follows Tasha, his fiance, on Twitter. For the purposes of our presentation today, we have included people who have Twitter accounts in our data set. So if someone doesn't have a Twitter account, then we've sort of omitted them from our analysis. So for example, Pilot Pete, he does not have a Twitter account. So you'll see that there are no relationships, or he won't appear in some of our visualizations. Okay, much like SQL databases, relational databases, they have SQL as the querying language. Neo4j, which is the graph database that we'll be taking a look into today, it uses Cypher as their query language. So of course, using that Cypher, we can query the database for specific patterns. And it's important to be able to query the database because we want to look for specific secrets or hidden patterns. If you're taking a look here on the right, this is a bird's eye view of the network that we've created using our data set. And you really can't decipher much information aside from the fact that Chris Harrison is at the center of it, which makes sense because he is/was the host. So in our case, you really can't tell that much from this database. So we need to be able to write queries in order to take a deeper look into our data. This is an example of a Cypher query that we have on the left here. And what this query is taking a look into is who is Sarah following that does not follow her back. So in this case, you can see the exact syntax that you could use to write this query. So here we have match path equals n contestant. So this represents a contestant that follows other contestants where those other contestants don't follow that particular contestant back. And so we are going to limit it to Sarah, who is here at the center of our graph, and return all of those different paths. So whenever we created this, we wanted to see who is following all these other people, but they aren't following her back. And Sarah appeared as the top candidate who follows a lot of people in Bachelor Nation who do not follow her back. So this is an interesting data point. And I guess it kind of makes sense because she was recently on this most recent Matt James season, and she was only in about 4 or 5 episodes before she left the show. So she doesn't have as much exposure as someone who has made it to the final 2.
Alrighty, so since our data is stored in a graphical way, we can use mathematical algorithms that already exist to provide further insights into the graph network we have stored. So I'm going to review some of the basic graph algorithms to introduce the capability of graph databases. Some of these algorithms are already included out of the box in Neo4j, and some of the algorithms come from a graph algorithm library that you can install with Neo4j. So I'm going to start off with a simple one. I'm going to start off with degree centrality. This is a simple calculation of how many incoming and outgoing relationships are connected to a node. You can customize this to only include specific types or direction. So for our Bachelor Nation network, we're only including one type, which is follows. In this case, I care more about who people are following rather than who is following that person. So in this case, you can see Chris Harrison is our #1 candidate. He is the most popular man. He extends over multiple seasons and is a pretty likable guy until recently. We did pull this data set before Rachel Lindsay, so it'd be kind of interesting to see if maybe he's fallen a little bit. But from the other top 5 connections, we also see a lot of our most favorite Bachelor and Bachelorettes. We also see people that have podcasts currently, so that could be another reason why they have the most connections. So on the graph side, you can see Chris Harrison is at the center, and he's kind of the biggest node, which means that he has the most connections. And then the size of the node is also indicating how many connections that person has. So you can see some of the other nodes like Zach, his node is smaller because he doesn't have as many connections. Another popular function is the shortest path algorithm. The shortest path algorithm will provide the number of hops from one contestant to another. In a relational database, this query can be really time intensive, but using an algorithm like this in Neo4j, it can be really quick and easy. So Neo4j has a built-in shortest path algorithm, which is a bidirectional breadth first search algorithm. So it's going to take, in this case, I wanted to be matchmaker, and I wanted to say, if I wanted to match up Trista from season 1 to somebody as handsome as Tyler C., who could I get that could link them up together? So what my algorithm does is it looks at Tyler C. and it looks at his relationships or who follows him or he follows them. That's 1 hop away. And then it looks on the other side at Trista and sees so who's 1 hop away from her. It takes the list of those contestants and says, do any of those contestants match? And in this case, we have 5 contestants that match, so I could call up JoJo and ask her to hook up Trista with Tyler C. in this case if I wanted to. Now, for the most part, since Bachelor Nation is so interconnected, it really doesn't take that many hops to get from one contestant to another contestant. There's going to be somebody that can connect the 2. But if I were to add more data to this data set, let's say I want to add Survivor or Big Brother, it may be a farther distance to get Boston Rob to connect to Hannah. So if that were the case, after it went 1 hop out and there were no connections, it would then go to another hop, and it might take 4 or 5 connections in order to connect Boston Rob to Hannah Brown. Next, I'll go over a graph algorithm that is more complex, and it actually comes from the graph algorithms library that you can install with Neo4j. This one is called Betweenness centrality. So it's going to take, again, the algorithm that I just discussed, which is the shortest path algorithm, and it's going to do that multiple times and look at all the shortest paths between all the nodes. So it's going to look at the shortest path between Kelly Flanagan and Hannah Brown, and the shortest path between Kelly and Tyler C., and the shortest path between Kelly and JPJ, and it's going to look at the nodes that it passes along the way. and it's going to calculate how many times that node appears in shortest paths. So when you get a high value of betweenness centrality, there could be two reasons why. One, it could be very highly connected. So I would suspect that Chris Harrison pops out pretty high because he's connected to pretty much everybody. So he's going to be involved in a lot of these shortest paths. Another person that pops out is somebody who connects two subgroups of a graph. So in our case, when we looked at the top people with a betweenness centrality, Justin Kendrick popped out. And at first, this kind of surprised me because I kind of thought it'd be a bachelor or bachelorette or even Chris Harrison. But Justin pops out because he's actually Pilot Pete's roommate, which we've said before. Pilot Pete does not have a Twitter, so maybe he would have popped out. But in this case, we have Dustin. And Dustin is a contestant that was on Hannah Brown's season, so he's connected to all the men on Hannah Brown's season. But then since he's Peter's roommate, he's also connected to a lot of contestants that were on Peter's season. And naturally, maybe not everybody on Peter's season follows the men on Hannah's season or vice versa. So he's kind of the connector between these two seasons. So if I am connecting Kelly to Hannah Brown, Dustin is the pathway in which that you're going to make that connection. So he connects the two subgraphs of these two seasons. So he can be an indication of a very important node on the graph. He's a linchpin between the two seasons and a connection point there. There are many algorithms that you can choose to play around with in Neo4j, just out of the box or using the Graph Algorithms library. They all have great documentation, so just go ahead and choose your favorite data set and just explore it. So moving on to graph visualizations, just as important as the output is or the algorithms are, it's really important to be able to visualize your data and really tell the story behind the data set. So looking on your left-hand side, you can see just out of the box what Neo4j provides. So Neo4j provides a browser that allows you to explore the data. It's really cool to use this visualization where you just want to provide a quick analytics or give a quick proof of concept. So I can put in my query up in the top, and then it'll output a visualization of what the data looks like behind the scenes. You're able to do minimal changes, so you can change the color, you can look at the size, so it can be a small node or a large node. You can also look at the labels. So for here, I don't have their Twitter handle listed. Instead, I have their full name, and then I also have the edge type follows indicated there as well. So there's a little bit of customization, but I really want it to look a lot nicer for this presentation. So I used a graph tool called Gephi. There are multiple reasons why I chose Gephi to use as our visualization tool for this project. So one reason is that Neo4j has another very popular library called the APOC library. The APOC library allows you to stream your results directly to Gephi. Another reason why I chose Gephi was it also has multiple plugins. So the plugin that I wanted to use allowed me to add a PNG picture to each node, so that way I could show each person on the graph instead of just having a color or a name listed on the graph. We can actually see a visual of the contestant. Lastly, Gephi provides a pretty good user interface, so that way it was really easy for me to change the color, the size, the shape, and just move around the nodes into the right location for my visualization. I simply just exported into a PNG and then plopped it into my presentation. So if I were to go through the workflow, in this example, I'm looking at my shortest path query that I wrote. So I wrote in a cipher query of the shortest path. I was able to look at what my graph will look like in the Neo4j browser. I streamed my results to Gephi, and then I played around to make sure I lined up my nodes the way that I would like it to look and customized it. And then I exported that to PNG and then put it in my presentation. So it made it really easy, simple workflow.
Thanks, Sam. So Sam told us about the powerful ways using Neo4j that we can visualize our graphs. So we decided to dive deeper into this in visualizations and use them to look at some interesting insights in Bachelor Nation and the relationships on Twitter. So first of all, we looked at who follows the most people. And this was motivated behind the fact that a lot of times people come on to The Bachelor and their intentions are questioned. Are they here for the right reasons, which is finding love and being there for engagement, or are they there to become famous and on social media after the show ends? So looking at who follows the most people, we found that Tammy from Peter's season follows the most people from Bachelor Nation on Twitter. She follows people that were on her season and also people that were from other seasons. So this might lead us to wonder if she was there just to network in Bachelor Nation and find fame on social media, or if she was really there for the right reasons. Next, we looked into some of this Pageant Queen drama which surrounded Aaliyah. And several people from her season do not follow her back on Twitter, which is kind of unusual because a lot of times on the show, although the girls are there to meet someone they could potentially be engaged to and married to, they also form very strong friendships by living in the Bachelor Mansion with the rest of the girls or men on their season. So Aaliyah was involved in several drama episodes on her season, and you can see that she follows several people on her season and they also follow her back. She's the middle of the network. However, there are 4 people from her season that don't follow her, and she also likewise does not follow them back. At the top, you can see one of those people that they don't follow each other was Sydney, who was involved in a lot of drama with Aaliyah after Aaliyah was eliminated and then came back. Another one of the notable people in which they don't follow each other was Victoria P., who accused Aaliyah of lying about knowing her prior to coming onto the show. So you can see this dramatic friendships play out in this visualization and how they don't follow each other on social media. And then finally, a lot of the relationships that are forged on The Bachelor, they continue and have ups and downs even after the show ends. So we look to see some of these exes in these past relationships. Did they end on good terms? Are they still following each other even after breaking up? This was kind of an interesting insight. So first, at the top, we have Dale and Claire, who famously blew up the Bachelor franchise by leaving the season early and becoming engaged after just a few weeks. And since then, they broke up, but now they are kind of getting back together, according to media reports. So you can see here that they still both actually follow each other, so there might be some hope for their relationship. Next, in the middle, we have Hannah B. and Jed. They ended on very bad terms after Hannah B., who was the Bachelorette, picked Jed as her final winner. And then they broke up after Jed had a girlfriend at home, which was released in the news. So they do not follow each other on Twitter anymore. And then finally at the bottom, we have Grocery Store Joe and Kendall, who recently broke up during the coronavirus pandemic, along with several other Bachelor relationships. And we can see that they still both do follow each other on Twitter.
Awesome. The next part that we wanted to put together is a casting call. So kind of like a call for action. If you love The Bachelor and you are interested in applying your data science skills, these are some ideas that we had. Obviously, this is a quick presentation, so we wanted to put together some ideas. I know that there has been some controversy in Bachelor Nation about race, and so if you're interested in the intersection between social justice and The Bachelor, I think it would be really, really interesting to take a look at the follower counts of people of color versus non-POC. So, can we take a look at their follower counts on Instagram, on Twitter, and then also take a look at their screen time. There is a Bachelor Instagram account out there called Bachelor Nation Data, and she does a really, really interesting breakdown of screen time that POC get versus non-POC each week. So if you're interested, definitely check out that Instagram. There are also more generic things that you can predict, like can you predict the season winner based off of trailer footage, things like that. One thing that I think is really interesting, and I took a look at last season, is the frequent words and phrases. So if you remember Claire's season, she always wanted a man who would show up for her. So if you wanted to, you could scrape captions of the episodes and read that into Python and take a look and do some NLP work around what exactly the most frequent words and phrases are people saying. So I know Matt James, his favorite phrase this season is "thank you for sharing that," after a contestant shares that she's falling in love with him. So I think it would be very interesting to pull together some kind of analysis of the most frequent words and phrases. Similarly, you could look at Twitter data, Reddit data to take a look at fan favorites. Who is trending, who do people really love. I know last season I was a huge fan of Joe. And so he also gained a huge following on like Twitter and Reddit, and he had the hashtag like Justice for Joe. So if you're interested in that, definitely you apply NLP to take a look at Reddit posts and see who the fan favorites are, and maybe predict the next Bachelor or the next lead. And with that, we just want to say thank you everyone for attending our presentation today. We had a really great time putting this together, and we are happy to take any questions you all might have now.
So if our panelists are ready, we can begin the Q&A session.
We are ready.
Okay, our first question is coming from Kelly. They're asking, does Jeffy interact with Power BI? Do we have the capability to tie this into Power BI dashboards?
So I'm actually a new user to Gephi, but Gephi has lots of plugins. I haven't seen a plugin that works with Power BI, but I do know Power BI already has some force-directed graphs that you could use to provide the type of visualizations that you would want.
Our next question is coming from Jessica. They're asking, do you think by including data from Instagram, you would have ended up with different results?
Thank you, Jessica, for this question. And actually, yes, I do think we would have ended up with different results just because on Instagram, that is a platform that contestants from Bachelor and the Bachelorette, they tend to use that more often. And actually, there's more contestants that are on Instagram with Instagram accounts than are on Twitter. So, for example, Pilot Pete, he was the Bachelor, and he's not on Twitter, but he is on Instagram. So we would really be able to see even more relationships. And then the second way I think it would be a little different is that we talked about this a little bit in the presentation, but after the show, a lot of contestants and bachelorettes use their platform from the show to go on and become influencers. And they mostly do this through the platform of Instagram. So in addition to just looking at who the contestants follow and follow back from the other seasons, we could look at their following overall from all users of Instagram, because that could give some information about their power of influence and which is how they monetize themselves after the show.
Mahati is asking, what are some examples of business problems / real-time scenarios where Neo4j is used?
I was saying I'm actually going to answer two questions at once because I see another one coming down the pipe about use cases at the bank. So I'll talk a little bit about some of the use cases I know about at the bank, and then talk about other use cases outside. So currently my project works on a data lineage tool that uses Neo4j. There's also other people I know at the bank that are using it to look at fraud rings or just transactions. So there's a lot of different ways at the bank that we can use it, but outside the bank, it's used a lot for recommendation engines. So for example, somebody like Walmart could use it if I buy a certain product. What other products could I suggest or give coupons for that person? So any data that's super highly connected, I'm sure other businesses use it a lot for social networks on Twitter or Google. Yeah, so those are just some examples.
Jessica is also asking, are there are there other data scientists that try to predict the winner of The Bachelor? It seems like there's a lot of data.
I can take this one. So 538 actually put together the initial data set, and this is a couple of years ago. So they actually ran some, used some machine learning algorithms to try to predict the winner of The Bachelor. Since then, there haven't been as many people. You can see like sporadic blog posts that try to do this, but 538 is the main one.
Jessica's asking, how do we make this a Kaggle competition?
Yeah, I think we should. I think Lily was saying that it was a 538 data set, and actually it was kind of stale, so we had to kind of enrich it with the most recent seasons and add Twitter handles to it. But I think it would be cool to like throw the data set up there and see what else other people can find.
Corey is asking, did anything surprise you with the data you found?
I think that was kind of the cool thing about, I'm going to kind of answer both of your questions. So like, I was learning some new skills in this project. And so I really think it's fun to take a cool data set that I know a little bit about and maybe I can find new insights into. So instead of like using some boring data, I'm using the Bachelor or Bachelorette data that I'm really interested in to explore graph algorithms, or in my case, graph visualizations. So I had a little more experience than Lily and Jennifer, but for them, it was more exciting to just kind of learn databases with a fun data set. So I think that that's, you know, one takeaway here is to pick a cool, fun data set that you're interested in and really explore it while learning new skills. The things that probably surprised me, I would say that, you know, there were certain things like Chris Harrison being at the center, like that was going to be obvious, but something like the Betweenness centrality and having other people pop out, sometimes I had to be like, wait, who is that? What was going on? What was that drama that was there? And so I had to do a little bit of Googling to remind myself maybe why people didn't like Aaliyah, or that, you know, Pilot Pete had a roommate that was friends with all these people. So I think that there was a little bit of both there.
Alex is saying you started with a comparison between SQL-based databases and graph-based databases. Any thoughts on the difference between document-based databases, MongoDB, and graph-based, thinking particularly about use cases?
I can kind of jump on that one. I've never actually used MongoDB, so I don't really have any experience in that, so that would be something that I could look into. I think for me, there's a lot of ease using Neo4j and graph databases, because when we were talking about building the data model, it was a lot of just like whiteboarding, and naturally the data model looks very much like you would probably write on a scratch piece of paper. So it does lend itself to being really easy to use, a low barrier of entry, which is really good when you're just starting out with these type of projects.
And Tim is asking, for people looking to learn more about graph databases, where should they start?
I can take that one again. I mean, I think that, like I said, Neo4j is a really good place to start. There are multiple graph databases. I mean, I'm obviously being a huge Neo4j advocate, but it's one of the first graph databases, and I do think that they provide a lot of great documentation. Also, once you download it, there's a really cool tutorial that they like to use, that Keanu Reeves movie, The Matrix. They like to use The Matrix as one of their data sets, and you can kind of explore the movies and who's in them, and they do a really cool tutorial on there where you can learn just a lot about the database. But I've mostly used Neo4j in my experience, and I've had a good time learning that from, I started as a beginner and now I've kind of grown to a regular user here.
And also I'll say, if the topic of data and related to The Bachelor interests you, there is a Instagram that's pretty interesting called @Bachelor Data, I believe. And that Instagram takes a look at all the, like, it's more of data analysis and stats of each episode. Things like screen time per person and stuff like that. That's very interesting as well if you want to dive deeper.
Yeah, I'll jump on that. It's really cool. And she uses a lot in just Google. So she uses a lot of Google Sheets and Google Analytics that I did not know was there until I started looking at the stuff that she was using. So I tried to steal data sets from her, but she wasn't given none of it.
We have another question from Taylor. She's asking, how do you see this data being useful when selecting new bachelors/bachelorettes Do you think that they will stay in Bachelor Nation or go outside connections for future Bachelor/Bachelorettes?
I think that's an interesting question. We talked a little bit about how people are always questioning, are they there for the right reasons when the contestants go on? And a lot of people criticize The Bachelor in more modern times by saying that they're selecting people who are only trying to become like influencers after the show. So I think you could probably use this data and to see if people, like Sam talked about in the presentation, if they're laying the groundwork for building those networks, like if they're trying to become an influencer, you might be able to use this information for that, or to see if they're actually genuinely there for finding love. And actually on this current season, there is a girl named Michelle, and she had no social media whatsoever before coming onto the show. Whereas some people go on and they're following every single person. So it could possibly be used to indicate their intentions.
I would say, though, that this would probably be a good indicator of who could be on Bachelor in Paradise or Winter Games or whatever weird, crazy singing season that they have next with all the Bachelor and Bachelorettes on it, because you can already see maybe what relationships already exist or what groups or cliques are already communicating together. And so you can kind of link the right people up, or maybe who's not following who. So maybe we would want Aaliyah on a Bachelor in Paradise season so she causes a lot of drama. I don't know.
I think we've hit our mark, but if you guys have any final remarks you'd like to say before we end, feel free.
Yeah, I just want to thank everyone for coming and joining our session. Oh, go ahead, Lily.
I just want to say we put this presentation together because we wanted to make people apply data science to something that you're interested in. Like Sam said earlier, it's really fun to put together or draw some kind of insight on something that you enjoy. So the three of us work on the same team and we all love to talk. We have a group chat to talk about The Bachelor. And so I just think that if you can find people who are also interested in these things and work on some kind of project together, then that's a great way to get into data science or further your skills.
Well, thank you all so much for coming to speak to us. And thank you for all the attendees for coming out as well.
Thank you. Appreciate it.
Thanks, everyone.